Computer monitor. A computer monitor is an output device that displays information in a pictorial form. A monitor usually comprises the visual display, circuitry, casing, and power supply. The display device in modern monitors is typically a thin film transistor liquid crystal display (TFT LCD) with LED backlighting, having replaced cold cathode fluorescent lamp (CCFL) backlighting. Older monitors used a cathode ray tube (CRT). Monitors are connected to the computer via VGA, Digital Visual Interface (DVI), HDMI, DisplayPort, Thunderbolt, Low Voltage Differential Signaling (LVDS), or other proprietary connectors and signals. Modern computer monitors are easily interchangeable with conventional television sets. However, as computer monitors do not necessarily include integrated speakers, it may not be possible to use a computer monitor without external components. Cathode ray tube. The first computer monitors used cathode ray tubes, CRTs. Prior to the advent of home computers in the late 1970s, it was common for a video display terminal (VDT) using a CRT to be physically integrated with a keyboard and other components of the system in a single large chassis. The display was monochrome and far less sharp and detailed than on a modern flat panel monitor, necessitating the use of relatively large text and severely limiting the amount of information that could be displayed at one time. High-resolution CRT displays were developed for the specialized military, industrial and scientific applications, but they were far too costly for general use. Liquid crystal display. There are multiple technologies that have been used to implement liquid crystal displays (LCD). Throughout the 1990s, the primary use of LCD technology as computer monitors was on laptops, where the lower power consumption, lighter weight, and smaller physical size of LCDs justified the higher price versus a CRT. Commonly, the same laptop would be offered with an assortment of display options at increasing price points: active or passive, monochrome, passive color, or active matrix color (TFT). As the volume and manufacturing capability have improved, the monochrome and passive color technologies were dropped from most product lines. TFT LCD is a variant of LCD which is now the dominant technology used for computer monitors. The first standalone LCDs appeared in the mid-1990s, selling for high prices. As prices declined over a period of years, they became more popular, and by 1997 were competing with CRT monitors. Among the first desktop LCD computer monitors was the ASO L66 in the mid-1990s, the Apple Studio Display in 1998, and the Apple Cinema Display in 1999. In 2003, TFT LCDs outsold CRTs for the first time, becoming the primary technology used for computer monitors. The main advantages of LCDs over CRT displays are that LCDs consume less power, take up much less space, and are considerably lighter. The now common active matrix TFT LCD technology also has less flickering than CRTs, which reduces eye strain. On the other hand, CRT monitors have superior contrast, have a superior response time, are able to use multiple screen resolutions natively, and there is no discernible flicker if the refresh rate is set to a sufficiently high value. LCD monitors have now very high temporal accuracy and can be used for vision research. High Dynamic Range (HDR) has been implemented into high-end LCD monitors to improve color accuracy. Since around the late 2000s, widescreen LCD monitors have become popular, in part due to television series, motion pictures, and video games transitioning to high-definition (HD), which makes standard-width monitors unable to display them correctly as they either stretch or crop HD content. These types of monitors may also display it in the proper width, however, they usually fill the extra space at the top and bottom of the image with black bars. Other advantages of widescreen monitors over standard width monitors are that they make work more productive by displaying more of a user's documents and images and allow displaying toolbars with documents. They also have a larger viewing area, with a typical widescreen monitor having a 16:9 aspect ratio compared to the 4:3 aspect ratio of a typical standard width monitor. Organic light-emitting diode (OLED) monitors provide higher contrast and better viewing angles than LCDs, but they require more power when displaying documents with white or bright backgrounds and have a severe problem known as burn-in. Please subscribe, like video, share, comment and click bell icon for upcoming videos.